Saxon Advanced Math Lesson 63. This is circles and completing the square. And we're going to start out, we're going to talk about circles first of all. And we've already graphed them before where they're given something like this, like a radius of 3, centered at 2, 4. And if I was going to graph that, I would say, okay, center at 2, 1, 2, up 4, 1, 2, 3, 4. And that would be my center. And then I've got a radius of 3, and I'm going to put that on there. This is a graph that we've done up to this point already. Now, if we wanted to look at this and say, how could I also define that? A circle is defined as the locus of points, which we've already understood as they're all the points that are the same distance from a given point, right? Our radius of 3 is all the same all the way around. Well, if I wanted to use that same idea of a locus of points all the way at 3, a radius of 3, I could say the distance is 3, right? And how far is that distance? What's the distance formula? What's the distance formula? Well, if I said that any x, y value on here, I would say how far away is this? I could say x minus 2, right? Because that's the center. And x minus, or y minus 4, that's the other piece of the center. And I could look at those and realize that this right here is my distance formula to define any x, y point. So if I said, well, I want to find out where x, y is right here. Well, I could do so by defining how far away this point is from this point. By saying x1 minus x2, right? X minus 2. y1 minus y2, y minus 4. And then I would square those and find the root of them, and that's going to equal 3. Well, if I square both sides, I'm left with this, and this looks suspiciously like our standard formula of a circle that we go ahead and graph with. Now, what if I were to take this standard form of the circle, but instead of leaving it as a standard form, I went ahead and multiplied out what x minus 2 squared is, and what y minus 4 squared is, and then 3 squared, I would get this right here, right? Because of FOIL, first outer inner last, or left to right, whatever method you use. When I do so, and I get this, I reduce this and I put it in the correct order where the squared terms go first. X squared, y squared, my negative 4x, right? My negative 8y. And then I took the 4 and 16 and subtracted the 11 from it, and I ended up with 20 minus 9, which is 11. And that's my general form. Now, so we already know the standard form of a circle looks like this one. The general form of a circle looks like this one. Well, that leads us to where this lesson is going to add to, or we're going to actually learn something new. So up to that's review, right, and explaining where the circle formula came from. Now we're going to talk about what if we're given the general form of a circle. And this is one that's unique because a lot of things in math, we can just stick in the calculator and it tells us what it is, right? If it's already in the y equals format. Well, it's not. I can't take this and stick it in my graphing calculator and expect to get anything out of it. So I need to be able to work with this equation because this is the general form of a circle that's being defined, but I need to know where the center is and I need to know radius, everything else will be easy. Well, if it was in this format like this, I could do so. Well, this looks suspiciously like a perfect square trinomial, and so is this one. So we're going to make them perfect square trinomials. How do we make something a perfect square trinomial? By using completing the square, just like we've done with graphing parabolas. So we're going to do just like we did with the parabola, but instead of doing it once, we're going to do it twice. And we're going to get an answer here that's very similar to graphing parabolas. So I have this as a general form, and I went ahead and just started rewriting things. Let me jump over here and put this. So I moved the x squared down. I moved the y squared over to here. I put the 6x down, I moved the 8y over, and I put the 21 on the right-hand side. And I added blanks with parentheses, not changing values at all, just putting it in order to complete the square. Now, if this was a perfect square trinomial, half of this term squared would be the third term. Well, half of negative 6 is negative 3, squared is 9. Half of 8 is 4, 4 squared is 16. But wait, I can't just add a 9 and a 16 to that half of the equation without adding it to the other half. Remember, this is completing the square. So I add a 9 and a 16. I'm really doing the same thing I did with the parabola, except instead of doing it on one side, I'm allowed to balance it on both, and I'm using the x squared term and the y squared term. So I have my negative 21 from moving the 21 from the left to the right, and I go ahead and add a 9 and a 16 to it. When I do so, I get 21 plus 9 plus 16, that gives me 4. Now, x squared minus 6x plus 9, I take half the middle term, right? And that's going to be my perfect square trinomial. My perfect square trinomial works because half the middle term squared is the third term, and so I already know what this is. I'm not guessing on the factors. This term is always half of that one. So x minus 3 squared, y plus 4 squared, right? And it equals 4. This looks really close to my equation. If I only had the root of 4 and then wrote it as squared term, 2 squared, I would have the standard form of a circle. There we go with a 3 and negative 4 as my center, right? 3 and 4. And my 4 is 2 squared, so my radius is 2. So I take the root of 4 to get this, and that's 2. Well, and that graphs in my fourth quadrant, just like that, like we've done before. But we've taken this that I didn't have a way to graph and put it into this, which is something I can. Now, let's talk about when it gets a little more exciting. This is example 63.3. And they gave us this one here, and 2x squared plus 2y squared minus x plus y minus 3 equals 0. This one is more difficult, not because it's just a third example, but I jumped to this one because this one actually introduces something else that we have to do. So when we're looking at this, we realize that I'm going to do just like I did on the first one to begin with. I move the 3 to the right-hand side. I move the 2x squared down. I put the x term with it. Move the 2y squared down. Put the y term with it. But in order to have a perfect square trinomial, I can't have that coefficient number in there. So I'm going to factor out a 2 out of this. When I do so, I pull a 2 out to the front. I pull a 2 out of my x, which is a 1/2. So in other words, 1 divided by 2, right, because I pulled it out. And you can always check this by saying, well, if I multiply the 2 times the x, that'd be 2x squared. The 2 times the negative 1/2, that gives me x again. So I know that I'm allowed to do so. So I pull the 2 out to the front here. I pull the 2 out to the front here. Same thing. This is where the book doesn't really give you an example, but there will be problems like this. If these two numbers are not the same, I will need to find a common unit between them to get them both to being 1. So I would need to do a little more work to get those both. I need them to have coefficient values of 1. Okay? Now, at this point, how do I get rid of these 2's? Well, I get rid of the 2's by just dividing both sides by 2. So I divide this by 2, divide this by 2, and divide 3 by 2. Now I'm really at the point where I was on this equation, right? Where I was right here, right? Except I have a half. Well, I can take half of a half instead of a whole number. That's just a fourth. A fourth squared is a 16th. So I add a 16th. Half of a half is a fourth. Squared is a 16th. And now I'm looking at this saying, oh, this is looking a lot better, right? Because now I can rewrite this as x minus 1/4 squared, right? Because it's always half the middle term. And this one, half of 1/2 is 1/4, so it's still half of the middle term. So it's x minus 1/4 squared, y plus 1/4 squared. But on the right-hand side, I have to add my 16ths back, right? So I have the 2 16ths. 1/16 plus 1/16 is 2 16ths. And then I've also got this, which is I had to find a common denominator. My common denominator is 16. 2 goes into 16 8 times. 8 times 3 is 24. So I have 24 plus 2, 26 over 16. Now, this is really close. I'm really getting close to this. This right here is going to give me the correct format, right? I'm ready to go, except that I need this term rooted. If I rooted this term, and I just realized they didn't simplify this, I could have taken a 2 out of both of these, and because the root of 26 would actually reduce down as well, they missed that one. That's okay. It's not the end of the world. That just would have given me a value here that would have canceled as well. But it still is going to be the same radius. So going back to here, when we look at this problem at this point, I'm going to take the square root of this and square it, just like I did here. Square root of this, and I'm going to square it. So I would write this 4 as 2 squared, right? I square rooted 4 and squared it, made it 2 squared. That's what I knew radius was 2. I'm going to take the square root of 26 over 16, right? Root of 26 over 16, and square it, and that gives me the same thing, because if I take the square and the square root, they're opposite operations, they're the same thing. So I'm going to get root of 26 over 4, because root of 16 is 4, squared. Now I'm ready to go ahead and write my answer, and graph it if I wanted to. R equals root of 26 over 4. I would probably put that on my calculator to find out how far my radius actually is, because this, I don't think in the root of 26 over 4 as a number, even though it is. The center is at 1/4, and negative 1/4. And there we've used completing the square with coefficients, getting rid of those coefficient values. Very simple, very easy to do as long as you follow the steps that we already know on completing the square and the rules of algebra that say if I add something to one side, I have to add it to the other side of the equation. This is a little more labor intensive than some of the problems we've done, but you'll be fine with this as long as you're willing to follow the steps. And it does make sense on why a circle is just a distance away, because all a circle is just a distance formula with equal to how far the radius is.